Let us build a movie recommendation app in Python where a user can select a movie that they like, and based on their selection, we are going to come up with some recommendation that the user may probably enjoy. So once they give the selection and ask for the recommendation, we are going to come up with a list of movies that they may like, as all these recommendations are based on the genre of the movie that they have selected and also content of the movie that they have selected. In this case, if you see, the user has selected Avengers Age of Ultron, and we come up with movies that are more of like superhero genre, right? So this is the content based recommendation system we are going to build. And apart from this recommendation system for these movies, we also build a particular service that's going to pull the plot of the movie and a particular image poster of that movie, so that the user can go through this plot and decide like if they want to watch which movie next. So this is the application we are going to build today. Hello everyone, I'm Siddharthan, and this is the project video that we will be working on. So in order to build this, first we would work on the exploratory code in order to set up the main art of this application, which is the building the recommendation system using Cosine Similarity, that to kind of understand the similarity between all the movies that we have in our dataset. And later we can build a sophisticated user interface in Streamlit where the user can have an interactive way of finding the movies that they can watch. So let's get started. So before going into the Streamlit user interface, let's quickly understand like how you can build this cosine similarity and similarity search system that helps us to say that this is the movie which is similar to the user selected movie. So that's what we are going to do first. So I'm in my Google Collaboratory now, so I'll connect this to my system. So this connects to a backend Python session. And the first thing I'm doing here is make sure that we have all the libraries that we need. So here we have NLTK, scikit-learn, NumPy, and pandas. So these are the libraries that we are going to need. So I'm doing a pip install, and this -q is nothing but install all these in quiet mode so that I don't see like a lot of outputs over here. And the next step is uploading the dataset file. So I have this movies.csv file. So I'll share the dataset link in this video description. You can download it from here. So you will find the repository URL, and within that you will find this like data set that you can access to. So it's called movies.csv, and it has like several rows and columns, which we will later like look at it. So this data set is getting uploaded, and now let's import the dependencies. So I'll run this cell. So first we have NumPy for some math operations, from numerical operations and so on, and then we have pandas in order to access this CSV file and do some processing on it. So we have some matplotlib .pyplot, which is to draw some graphs and plots to understand this data set better. And then we have TF-IDF vectorizer, which is basically used to convert your words that's present in this movie content, right? So movie genre, and convert it into words so that the algorithm can understand that. And then we have this cosine similarity algorithm, which is the key part of this application, which is used to find similar movies for a given movie. And then we have word cloud, again for building this plot to understand the dataset better. And then we have for data pre-processing of this text, we have RE, which is the regular expression library, NLTK, which is natural language toolkit, and we have stop words of word tokenize. So we will discuss about all these things once we kind of use this. So this is the first step, which is importing all the dependencies. So the next step is reading this movies.csv file. So for this we are using this pd.readcsv movies.csv, and we are storing this in a variable called as df, which is the data frame. So I'll run this. So this is going to save this data set in this variable called as df, and then you can do df.shape to see like how many rows and columns are there. And then you can also run this df.add two is just going to print you like two rows. So here we have index, budget, genres, home page, keywords, and so on. So we have like several of these things. And then we have like df info, it just gives you the data type details and whether there are any missing values and so on. So we get like all this information. So this is the data set that we are going to work on. And the thing is, it's not like the only data set that you can use. If you can curate a larger data set, that would be a better way, because then you can kind of like recommend from a even larger data set size, right? So that would be a better option. But this is kind of a generic data set that we can use. And previously I've also made a video on music recommendation system. So that's like how you can recommend songs to the user based on the lyrics. So that is also a content based recommendation system, and this one is like very similar to this. So if you have watched that video, you will find that this is like pretty similar to this one, but again you can scale this up for any other recommendation content based recommendation system. So let's see like how we can kind of process this data set, analyze this data, and build this content recommendation system. So here we see that we have index, budget, genres, like what's that movie is going to be, the link, probably like the link we can check it, and we have an ID and all those things. So what we are going to do today is, as this is a content based thing, the important aspect that we will use from this data set is overview of the movie. So you have like a overview of this, what this movie is about. So if you look at this, we have this original title as Avatar, and it says like the overview about this Avatar movie. And then we are going to use this genre as well, genre and keyword, so that when a user, let's say, gives this movie name as Avatar, we know that what is this movie is about, what is the genre and keywords, and based on this we can like recommend other movies as well. So this is like the main idea of like how this is being built. So the step next after this is to process this data set. If there are any missing values, or we can clean this, and we have like 23 columns, but we don't need all these things. Like we can just like simplify this by just taking the key columns that we have discussed, which is the genres, keywords, and overview, and we can just build on top of that. So in the next place, like this is what we are doing. So we are filtering this data frame where I'm saying that I'm going to need only the genres, keywords, overview, and title column. So if you want, you can also kind of include the director column and the crew column, if you think that we can also recommend based on the person who have acted in it or the director in it. Because usually when we recommend movies to our friends, we also consider that as a factor, right? But this is again more of content based, so I didn't include that, but you can definitely try that as well. So I'll run this. So this is going to filter this. So previously we had like all these 23, 24 columns starting in this index column, and now we have filtered this. So now if you check this shape, it's going to be 4,803 rows, but now we only have like 4 columns, and those 4 columns are genres, keywords, overview, and title. So these are the things that we have. And now let's check for missing values in these 4 columns. So it says that totally we have 4,803 rows, but genres has some values missing. So non-null values means 4775 values are present. In this case, 4391 values are present, and so on. So title is like everything is present. Overview is like for 3 of these overviews are missing. To just add things simply, I'm just like dropping the rows which has missing values. Again, this might not be the best way. Again, this is, I'm doing this just to make the demo a bit simpler. What you can do is like, even you can consider the ones where overview is missing, or like if either one of the genres, keywords, overview is present, you can keep it as such. But again, for simplicity, I'm just like removing the ones that has missing values in a particular column. And again we are checking this, and finally we have like 4,387 rows. So we started with like 4,803, but again there is a drop about like 500 or something, but that's okay for now. So this is the initial processing that we are doing. And the next step is we are going to combine the columns that we have. So the genres, keywords, overview. So we are not combining the title column, but rather we are just focusing on the content, which is, it says genres tells like what this movie is about, like what type of movie, and keywords would tell that what does the movie talks about. So genre is like the style of the movie, and mainly keywords is like what does it talk about, and overview is just a gentle information on what this movie is about. So we are going to combine all these texts together, and later we can process this text together, and this text, combined text, will be used for the recommendation purpose. So I'll run this. So here we are basically creating a new column. So previously we had genres, keywords, overview, and title. So along with this, we are creating a new column called as combined, and then just like joining all these things with a space. So if you now run this here, you will see that we have combined like all these genres, keywords, and everything. So we have like combined all those stuff. So the next step is like, this is just like looking at the sample of the data. So df it is going to print the first 5 rows, and df.tail is going to print the last 5 rows. And then we have this df title combined. So here what we are trying to do is just have a data frame where you have only the title and combined column. So now we don't need this genres, keywords, and overview, because we have anyway combined it to a single column. And now we are going to work with only the titles and the combined. This is to say that the content of this movie bank is given in this combined column, and for this particular movie it's present in this column. So now you have a title and a content mapping. So we are going to need is these two things, as combined is nothing but the combination of all three columns. So you can just like safely remove this. So data is equal to df of title combined. What it does is it just creates a filtration on this data frame called as df, by just taking this title and combined column and put it in a new variable called as data. So I'll run this. So that's how you can do this. So you can mention the data frame name, which is df, and then within that mention a list that contains the name of the columns that you want to filter. Now again do a data.it. Now we are not working with df, but we have changed it to data, and now you have only the title and combined as the column. If you want, again you can check the shape. It says 4387 rows and 2 columns. So now we can also understand like what are all the things that the movie is talking about, and you know what are all the words that have appeared a lot in this content, so that it gives an idea of what are all the topics and things that the movie is about. So it's like kind of a good analysis thing that we can do. So what we are trying to do here is, again, this is for the analytical purpose, and after that we are not going to use this. So here we are joining all the rows of this combined column. So it's basically like creating one large string where we are going to combine all the 4387 rows of combined column value. It's like this first column string, this action adventure fantasy, is combined with like all the other things. So it's like you get one big string which is a concatenation of like this entire column. So that's done by using this space dot join df combine. So what it does is it takes the column combined and it's going to join all the rows with the space. So that's why we have this. So it's going to join it with the space. What it's going to join is df dot combine. And then we have this word cloud that we have imported previously. So here if you see, we have this word cloud that we imported from a library called as word cloud, which is already like pre-installed in Colab. So we are using that. So in this word cloud, you are mentioning the size of the plot, height of the plot, what's the background color is, and say dot generate. So this is the function that we are using, and then pass the combined text, the text that we have combined. So now we have this particular data. Now you have to build a plot on top of this word cloud data. So you say that plt.figure, which is setting up the size of the plot, plt.time should just display the image. So we have this word cloud interpolation, whether you need access or not, and give a title saying that most common words in the movie content plt.show. So this is going to give the most repeated words in the content. So when we run this, this is what we are saying. So how we have to infer this is, if a word is large and it is bold, that means it has appeared so many times. If you see this science and fiction, so this is like kind of larger and bold, that means like a lot of movies are kind of like based on this, and you see this particular word a lot in your data set. And then you see this word called as love, and you have this life, family, friend, and so on. So these are like kind of the common words that are repeated. So this gives you an idea of what's the movies are talking about and what's the majority of the movies are talking about. So it's like good to get a feel of what's this data set about. So that's why we are building this word cloud. And in the next step, we are going to process this data. So for this, we are going to use a library called as NLTK that we have imported previously, which is Natural Language Toolkit. So from this, we are downloading this punkt punkt, which is kind of a tokenizer. So we have this punkt and punkt tab and stop words. So tokenizers is going to we have kind of several words in a particular line, right? So tokenizer is going to separate all these into smaller chunks. So there are different kinds of tokenizers. We are going to use a word tokenizer which just splits the text into individual words. So we need to kind of download all those tokenizers, and stop words is a key thing here as well. How this recommendation system works is before converting it to numerical values, or what we call as vectors, we need to take only the important words. But in that process, there are some very common words in English. It can be the articles like a and the and so on. And there are words like is, are. So all these words would be repeated a lot of times, but they doesn't have a unique meaning, because they're going to appear in all these rows, right? Because these are common words, and but doesn't have a lot of meaning if you just take it separately. So these are called as stop words. And when we build this recommendation app, when we are building this data set of vectors from these words, we don't need this, as this doesn't have any meaning. So what we are trying to do here is remove these stop words from your data set. So for that, you first need to identify what are those stop words are. So from NLTK, you can download the stop words and create a list of the stop words, and then you can filter out all these stop words from your original data set. So that's why we need this stop words. So once we download this, we are creating a set from this stopwords.english. So when you run this stopwords.words English, you can see what are all the stop words if you just print this one. And we are running this set to make sure that there are no duplicate values. So a list can have duplicate values, but when you put it into a set like all those duplicate values are kind of removed, as a set data type doesn't allow duplicate values. So we are kind of like doing that. So you can see build an unordered collection of unique elements, as it says. So it a set basically would allow only the unique values. So we are creating a stop word set that has like unique stop words in the language English. And then we have a function called as pre-process text, where some we are going to like basically clean this text. So we have this regular expression, so this re library that we have imported, and we are going to have basically filter this out such that we don't have any characters or numbers. So we don't have any special characters or numbers like the symbols and all that, and we don't have any numbers. So we are just going to stick to only the alphabets. So if let's say there are some numbers and some things like in the content, we are going to remove that. So that's the first step in this pre-process, where let's say in this case, like some special characters, ampersand, and some symbols are present, we are going to remove that. And again, we have this 2013 and other stuff, some numbers are there, so we are going to remove that as well. So that is the first step. And then next step is just to keep, again, think simply, we are converting all the letters into lowercase letters. So after this processing, you will see like all this uppercase letters will also be converted into lowercase letters. And the next step is the tokenization part. As I said, we would kind of chunk this into smaller piece of data. So here we are using a word tokenize, which is going to split a particular line into individual words, so that later we can convert each of these individual words into kind of like numerical values, or what we call as vector parameters. So for that, first we need to split this data. So we are using a word tokenize. So when you put a string into this, like again, a string can be multiple words. So when you kind of put this into word tokenize, it's going to split it into words or individual tokens. And then we are checking if that word is present in the stop words. So this is nothing but just like splitting the entire statement or line into individual words, and we check if any of these individual words is a stop word that we have already created from the stop word set. So here we have written a list comprehension. List comprehension is basically like creating a list using a for loop. So what we are doing here is we are iterating this over the tokens. Tokens is like all those individual words that we have in a particular line, and then we are checking if that word is present in the stop word. Like if it's not present, then include it here. So if you just read this, right, word for word in tokens, if word not in stop words. So basically what it does is it if there are like 10 words in this first statement, let's say that we take this first row and there are like 10 words in this particular row, it's going to iterate over all those 10 words, and for each of this word it's going to make sure that it's not present in stop words. If it's not present in stop words, that means it says that it's important, because stop words are not important for us. So it says that this is kind of like important. If it's not in stop words, it's important, then put this in the list called as tokens, and then return the joined tokens. So the different processes that we are doing here is we make sure that we remove the special characters and numbers. So here we are saying that A to Z and A to Z. This is saying that include all the alphabets between A to Z and A to Z uppercase. This would just only allow the alphabets and not numbers and special characters. In the next place, we are like kind of converting all those into lowercase letters and create tokens. That means create individual words and then check if they are present in the stop words. So this is like the initial data processing cleaning step that we do, and we are going to do this process for all the individual rows. So that is the next step. So now we have a function called as pre-process text, and we are going to apply this function to all the individual rows that we have in our data frame. So that's what we are doing here. So that can be done by using this apply function. So data frame has this function called as apply, where you can mention a column and you can pass a function as the parameter to this apply. So what it does is, here we are creating a new column to this data frame. So data is nothing but the data frame that we have initially filtered, right, the title and the combined column. So we are creating a new column called as cleaned text, which eventually we are going to use. And this clean text is nothing but we are taking this combined column, and for each of the row in this column we are applying this pre-processed text. So I'll run this, and now let's see how the data has changed. So this is a warning, it's not a big thing, so you can just like ignore that. It says that we are kind of creating a copy of that, so that's okay. So now see this, right? So here you have this action, adventure, fantasy, science fiction, and so on. So all these words have been like now in lowercase letter. Again, apart from this case conversion, there are also other things that has happened in the back. You're not seeing that because we are just seeing a truncated output over here. So it would have like removed all the special characters and numbers if there are any, and it would have like kind of created the tokens, and then like it would have removed the stop words and then like joined all these words. So that's like the final output that we are seeing here. So the next step is computers and systems and algorithms doesn't understand words, it only understand numbers, right? And what we are going to do is convert each of these rows into vectors, or what we call as feature vectors, so that you can find the distance between two vectors. So here we have this vectorization with TF-IDF, which is term frequency and inverse document frequency, which is basically to gives you the importance of the words. So we have this TF-IDF vectorizer, and then we are using this TF-IDF vectorizer, which we have imported from, so in this part, so you're seeing this sklearn.feature extraction.txt, we are extracting like using this TF IDF vectorizers, right? And we are saying that extract, let me go here. So we are creating an instance and saying that max features is 5000. That means it's going to determine the top 5000 important words in this entire data set. So here you have like, let's say 4300 rows, so 4300, these particular strings are there. So we are going to determine the top 5000 important words. So out this top 5000 words is determined as using this TF-IDF. TF is basically term frequency. That means if a word has appeared several times in a particular row, in a particular line, that means that word is important. But what this inverse frequency means is, if a particular word has appeared in several lines, then it doesn't make much difference, so it is not that important. Again, think about this stop words in this case, right? uh, like if it's present in all the rows, it doesn't make a difference, so we don't need this. So what it does is, term frequency and inverse frequency, it's going to assign importance to each of the words. If a word appeared like kind of several times in one particular case, it's going to get higher importance. If a particular word appears several times in several individual data points in several rows, then it doesn't get that much importance. So based on this particular idea, it's going to find out like those top max features, top 5000 words. This numbers can be changed, like again we can experiment with different numbers and so on, but for now we have to choose like kind of 5000 words. And now you create a TF-IDF matrix. So we are using this TF-IDF vectorizer that we have initiated, and then we have fitted and we did a fit and transform this entire column called as clean text. So what this does is, it takes each of this row and convert it into a vector. So the reason we are doing this is the purpose of finding the similar movies. Just think about this. Let's say you have two vectors. I'll search something like distance between vectors or something, or let me search something like similar vectors. This would give like a better idea. Okay, so in this case, in this particular image, right, let's understand this. Okay, uh, similar vectors are the ones which are closer to each other. So when you have two vectors, you find the distance between them. If the distance is smaller, that means two vectors are similar to each other. If two vectors has a larger distance like this one, the second case, that means they are like very different from each other. And this kind of represents like opposite vectors. They are like kind of completely opposite to this. And this is what we are trying to do. So we cannot directly look at the words, look at the alphabets and the words and say that this is similar to this is not similar to this. We cannot say that. So instead what we are doing is, we are converting each of this content, each of these movies into vectors, representing that in the vector space and saying that these two vectors are closer to each other, or in other words, these two vectors have a very smaller distance between them, so that means these two vectors are similar to each other. So that's what basically happens here. So we convert all these 4300 movies into vectors, and we take each of this movie and compare it with every other movie, right? So let's say that one movie is about this Avengers Age of Ultron, so we get the content, we convert it into a vector, and then we have 4299 movies. So we try to compare it with all these 4299 movies and come up with the distance score, or a cosine similarity score, which tells you how much this particular movie is closer to that movie. So for each of this movie, let's say you get 4299 scores, which is how much similar it is to the other movies that you have. So similarly, you do this for every other movie that you have. So it's like for each movie, you compare it with all the other movie and come up with a similarity score, and that's what we are going to do in the next step. So this TF-IDF vectorizer part just like convert all this data into vectors, and those vectors are saved in this TF-IDF matrix, and each row in this matrix represents one movie that is getting converted into a vector. So that's the first step. And then we are using this cosine similarity, which is basically used to find this distance between the two vectors. So when you do this, it's going to help us understand like how two vectors are kind of like similar to each other. So we are doing that by comparing TF-IDF matrix with again the same TF-IDF matrix. So it's like you just take this and compare it with like all the other movies that you have, just like the one that I've told you. So for each movie, we are going to compare it with like every other movie and come up with a score, a similarity score that we can later use in order to recommend. So now we have this, let's say, a matrix called as the cosine similarity, that has information on like if you take one movie, how it is similar to a particular movie. So you have a score for this. So let's run this. You can also print and see this. Not sure if that would make more sense, but we can just see it anyway. Right, you have some values, right? If I just put 0, so all this like kind of gives you the cosine similarity. So all the values are between 0 to 1. We kind of see this 1 because this is getting compared to the same movie. So in the first case, like first movie is getting compared to the same movie, so we don't kind of take that. So that's why you're seeing that 1. But we can just like come back to this later. So we are handling that later as well. So this is like when someone asks you to recommend a movie that's similar to Age of Ultron, it's saying like watch Age of Ultron. We don't do that, right? So but here we are taking a movie, comparing it with all the movies in the dataset, and we are getting 1 because it's basically exactly the same movie, which we will later kind of remove that from this recommendation. So that's the thing. So later we have this kind of prediction script, or what we call as a recommend movies function. So that's going to take this movie name. So here I've written this as song name, but we can change this to movie name, as this code is kind of very similar to the movie recommendation that we did. So let's see. Okay, so we have this recommend movies function that's going to take a movie name as the parameter. This is what the user would give from this, Streamlit user interface. So they give a movie name, and then we pass this cosine similarity that's basically this matrix that has information on like how the movies are related, right? So we have like those particular thing, and then we have this data frame. Data frame would be the data, the process data. DF is not the initial DF that we have assigned, so this is the parameter name DF, and we have to pass this data, like the process data that has like this title and combined thing that we have, so that later we can find the movie names. Top n says like how many recommendations that you have. So this is also configurable. You can build it in such a way that you're suggesting like 10 movies, 20 movies, or like any number of movies, but here we are sticking to 5. So what we are trying to do here is like once the movie name is given, so from this data frame we are trying to find the index of this. So if this index is not present, we are saying that that's not present, because this recommendation is going to work for only the movies that's present in this data set. So first we have a validation to check if the given movie is present in this data set, and if it's not present, we say that it's not present, and if it's actually present, we are finding the index. So it's like if you take this first movie, let's say the user types in Pirates of the Caribbean at world's end as the movie. So we come back to this data frame as that we are passing, and from this we are finding the index. The index is nothing but 1 in this case, right? So we kind of find that index and store it in the variable called as idx, and now we get the similarity score, because this represents the similarity score. Like if you just take this one, right? So cosine similarity of 0, that's like similarity of the first movie with every other movie. If you check the length, it's going to contain 4387, the total number of movies. That means it has like, if you take the first movie, let's say Avatar, how much similar this Avatar movie is like to like all the other movies. So that's the score that's present over here. So the first row represents the first movie's similarity score. The second row represents like second movie's similarity score, and so on. So let's say that I'm putting this 1 and running this. So we have like all these other movies. Totally, there are 4,387 rows are there, and this one represents that actual movie. But so we should just like ignore this. Let's see how we can do this. So you are passing this index to identify the similarity score for that particular movie based on the index, and you are creating enumerate. Enumerate just like gives like all these values individually, but also again with the index. So index in the sense it would give this 1 comma 0.29 and then 2 comma 1 3 comma 0.03 and so on. So it's going to give the same list, but it's going to attach an index to this. And what we are now doing is sorted. So sorted based on the similarity score that we have. So the process data would look something like this. So it would be like 0.0 to the entire number, and it would contain a value as 1, and then it would contain something like this. So 1 is the second index, so it would be like, yeah, suppose we put the index and put the value 0.02 like this entire number, and the second index is 1 and the value is again 1.0, the number that you are seeing over here. So this process goes on. So now we are sorting the similarity score that we get. This like this entire thing kind of forms a list now, and we are kind of like reordering this based on the second value. So we are reordering this based on the similarity score. So now you have for a given movie, you have all the similar movies because we have kind of have this in descending order. So the most similar movie to the given movie will be on the top. The second most similar movie would be in the second place, and you would just like order all these 4,387 values. So we are putting this reverse to get this in the reverse order. And finally, we have this, and we say we are just like slicing this so that we don't include the first value, because the first value is that movie itself. So it's just like the entire idea here is like, given a movie, you get all the similarity score for every other movie you have in your dataset, and just order this in descending order so that you first have like the most similar movie all the way down to like which is like the least similar movie. So you have that list, and then you just remove the first element because that's the same movie itself. So we say that give everything after the first movie, and that is your similarity score. And using the similarity score, again we find the indexes, put these indexes back. Like again, let's say for Avatar the similar movies are 3 2 1 4. This is the order. We put this index back to this data frame and find what's the movie name for 3. So it's Dark Knight Races, and let's say after it we say that 2 is the next similar movie, which is Spectre. So we give that, and final result list that you get is, let's say, Dark Knight, Spectre, and then like all those things. So that's how we are building this recommendation system. So it's like first we are combining all the content of this movie and putting it into a vectorizer to convert it into vectors, and using a cosine similarity to find the similarity between all the vectors that we have. And finally we create this cosine similarity matrix using which we are going to recommend the movies. So all these titles are like present over here. So we'll run this. Okay, so this recommend movies is what we are going to call. All these are like optional parameters. So we have like kind of give this as like default parameters in the function itself. The movie name is something the user has to give. So if you want to test it, you can just like check all the movies that you have, and you can just like give a movie from this. So let's say that I want to test it for the Avenger Age of Ultron. I know that Avengers Age of Ultron is present in this dataset. If you want to check, you can just like run this code. So we are trying to find the row index. What's the index number? This particular number, and you say that df or df title is equal to Avengers Age of Ultron dot index. So what it does is it tries to find the row that has this value in its title. It's basically like finding in which row this movie is present and find that index. And when you run this, it's going to say it's present in index 7. So in like line numbers 8 or index 7, Avengers Age of Ultron is present. If you want to look at this Batman versus Superman, in that case again you can just like replace this, and that would give the indexes 9. So let's say that 7, which is Avengers Age of Ultron, we have to pass this to the recommend movies function. So that's going to recommend this. So I'll run this. So we have movie name over here, and we are passing this movie name to the recommend movies function, and that's going to recommend the movies. So we have Iron Man 2, Iron Man, Avengers, X-Men, and X-Men. So this is how the recommendation works. So you can just like download the CSV, which you have like probably would have already downloaded it. You can just open this and maybe search it in Notepad or somewhere. And if you are looking for a specific movie, let's say that you're looking for like, let's say, Batman movie or something, you can just like search it from the Notepad, and that would tell you like if it's present or not. If it's present, you can put it through this particular code, and that gives you like the recommendation for that particular movie. So that's the entire idea. So let's say that we want to check it for Batman as a Superman, which is present in this line, sorry, the index number 9. So if you run this, you get the output as Man of Steel, Superman, Batman Return, Superhero, Movie Defender, and most of the top recommendation are from Batman, and it's great that it's able to link that and give this suggestion. So this is the main art of this recommendation system. And the next step that we have is like how you can for a given movie, how you can pull this plot and how you can get this poster image from the third party API that we can use. So that is the next step, and how to kind of build this user interface in Streamlit. So for retrieving this poster and plot, so I'm using this API called as OMDb API. So you can just like go to Google and search for OMDb API. So we have this the open movie database. So this is the API that we are using that as like information on like several other movies. Again, you can use this to create your own dataset itself. So our dataset contains 4,000 rows, right? So similarly, you can also you know use this API, just get like large amount of data and build your own data set as well. And they have given the documentation on how you can call this API and so on. So it's like, let's say you want to search a title by saying Avengers Endgame. Here it's like an optional thing plot. Let's say I say that give me a full plot and search it. So it's going to give like all this information, title of the movie, what's the year, rated, like the cast and crew. So all this information can be pulled from there. And you also have like the plot given here, like what's the movie is about, the plot after the devastating events of Avengers Infinity War, like all these are mentioned here. So this is just to look at like how we can basically like what's the movie gives us an output. But the one that we are interested in is like the plot, right? And also like the poster for this, let's see how we can kind of get that. So in this thing, right, poster is given here, right? So we're going to use this and extract this plot as well as poster and display it in the Streamlit user interface. So for this you need the API key. So you need to go to this API key, do a sign up and generate the API key. So once you request that, a mail will be sent to you and you can activate the API key from that mail itself. So after that, you need to write this script. So you need to pass the movie title and you need to pass the API key. So you kind of like construct the URL like this. So omdbapi.com title. So this title, this is a variable as we are putting this in a F string. This title will be substituted with the title that the user is giving to us in the this particular drop down. So it will be replaced here and the API key will be replaced here as well. So we will pass the title as well as the API key. The API key that you're going to get from this OMDb API key site. Okay, so that's how we have to do this. So we call this URL. So we call this get URL, convert it into JSON. If the response is successful, then the response.get of response should be true. If it's true, we kind of get the plot and the poster value, and then we later process it. So we display the plot, and for poster you just get a URL. So you kind of like load the image from the URL and then we are going to display it. So let's see how we can do that. So again, this is about that third party service to just like handle the second part of how to get the poster and the plot. So the one that we are seeing over here. So now let's see how to build this user interface and how we are using this recommendation system that we have built. So I'll come back here, close this thing, and maybe I can delete all those files so that I can show you how this entire thing works. Okay, so now this app would have been stopped. Right, so let's understand this. So here we have multiple files. Maybe first I'll delete all these things. So all these files will be generated on the runtime. So I'll again give a you know repository that you can use in order to uh, so that you can use that repository to download the files, or you can clone it in your PyCharm and you can just like build this project. So you will see that, but you don't see that pickle file and so on. Don't worry about that because all these files are going to be generated in runtime. And another important file here is this config.json, where we are going to save our API key. So we shouldn't put our API key explicitly in our code. Like in this OMDb thing, we are using that API key, right? So we will kind of load that from this config.json file. So this config.json file has the API key. So we should kind of load this because now my API key is not explicitly present in the code so that others cannot use it, right? So that's the standard way we have to follow. but I'll show you how this config.json looks like. So create a file called as config.json, but again, this will be present in the repository as well. It would basically contain something like this. It's kind of a dictionary, basically a JSON object which has a key value pair. So the key would be OMDb API key, and here paste the key that you get in your email. Again, you have to go to OMDb API site, get the API key. Your API key will be mailed to you. Activate the API key. They would also send you a link below that API key which you have to use to activate. So after activating, it's like kind of a 6 letter 7 letter string or something. So just like paste it between this code. So replace this your OMDb API key with the actual API key. This is just a template file. You don't need this, but you need this config.json. Just like replace this, put this entire content in the config.json, and then you are good. So only if you do this, this OMDb API can be accessed, as we need to pass this API key over here. So that's the process. So the only difference that you have to make is once you clone the repository or the download the files, generate your own API key, put it over here. So those are the things that are expected. So now let's see how we have converted this notebook script into notebook content that we have seen over here into a Python script. It's basically the same code. It's just like we are putting all these things through a script. It's like the same thing. So we have this NLTK pandas and everything. So here we are reading this movies.csv and then processing this. Like it's exactly the same thing. The only difference is that we have added logs so that we understand if something goes wrong, like where is the issue and what's the particular process going on, whether it's like starting process, whether the process is about loading the data set and so on. So we have added logs so to monitor like if there are any issues or like where exactly some issue is happening. To monitor that, we have added logs. And apart from that, like every process is same. Like basically what we have done this, you can just like go through this, and again, if you understand this notebook code, this is like pretty simple. And the other thing that we are doing is making sure that we are saving all these files that we are going to need. So all these files are the ones that your recommend movies function needs. So it needs cosine similarity, df, the data frame, and the top end we can give, but we need this cosine similarity and df, right? So that's what we are saving here. So we have tf df clean and cosine similarity. TF-IDF matrix is the previous step. We don't need this, but just in case we are saving this matrix. But this df clean and the cosine similarity are the ones that's very important, because we are going to need this for this movies function. The reason we are saving this is saving as files is we don't want to build this every time we need to make a recommendation. So rather we build this entire matrix, keep it aside, so whenever someone asks for the recommendation, we can just use this data and give the recommendation. So that's the step. So the first script, as the name suggests, is a pre-process script which is going to read the CSV data and it can like process this. So if you are having a different data set which is similar to this, right? Different, but different in the sense like it has, let's say, more rows, the same column names. You can just like use this particular script. Let's say that it doesn't have this genres column. It has a column called as plot or something. You can just like replace small details. Let's say your data set has 50,000 rows. That's much better, right? So you can just like replace few of these stuff here. So this kind of access like the base code that you can use, just change the code wherever required, and this is like good for that particular data set as well. So this is a pre-process script. And later we have this recommend.py script, which again does this function of recommend movies. So we have this recommend movies function. It does the same thing. So we have movie name and everything. So we just like give the recommendation. So finally we come up with data frame, which is basically the list of the movies that we are going to recommend. So this is the output of this recommend things function, but it's going to just give this in a proper data frame with proper numbering. So here you're seeing this 14, 8, 6, and 4 to 4 and so on, right? So instead we are going to name this as 1, 2, 3, 4, and 5. So that's like the additional two things that we did. So apart from that, everything is like what you are seeing in this particular function. So it's like the same recommendation script. And again, we have just added the logs over here, and this part is we have already saved the data frame and the cosine similarity as pickle files, right, in the pre-process function, so that we are loading it back to recommend py so that we can now use it within this recommend movies function. So that's the idea. In the pre-process step, these files are getting saved and later we are using in the recommend movies function. So that's the entire thing. So this I can comment this. This is just to test if it's working, but we don't need this. Okay, we can also even delete this. That's not required. Okay, so this is the thing. And now we have the main.py. This is all about like the user interface that we have for our Streamlit application. So this OS also we don't need as. we have this JSON in order to read this config.json. So I've told you, right, this config.json as your API key. So we have to read this API key and save this in some constant thing, something like OMDb API key. So you can, this is kind of now converts this JSON data into a dictionary, JSON.load open. So we are opening this JSON file and converting its content into a dictionary using this JSON.load. And this dictionary value you can extract using the OMDb API key, which we will later pass to this function called as get movie details, the OMDb utils that we have. So this is again, you know that it's going to give you the plot and poster. If for a given movie couldn't find that movie details, it's just going to give NA not available and not available as a response for plot and poster. So that's the idea. So how this entire thing works is, so we have Streamlit, recommend, OMDb thing, and so on. So Streamlit, to build the Streamlit user interface, recommend, from this we are importing the data frame that we have loaded and the recommend movies. Again, the recommend movies function, which is the base thing, right? So when a user gives a movie name, we pass it to the recommend movies thing and we get the recommendations back. OMDb utils get movie details to get that plot and the poster details. So we are loading the configuration, saving the API key. Page configuration is like each page would have an icon, something like this. If you see collaborator, it has this particular icon on name on it, right? So that's about it. So this gives the name of the page and the page icon, whether you have the content to be centered in one place or you want like a wide layout. So that's about this, giving a title and so on. And then we have, so from this data frame, this is the reason why we need this data frame. So we create a list of this data frame called as movie list. So we sort this, drop any missing values and sort this title column and create a select box, a drop down from which the user can select a movie. And then we are creating a button called as recommend similar movies. So once they click on this button, so we are going to pass that movie name that they have selected to this function called as recommend movies. So it's then going to call those function, do all those search on the cosine similarities. So in the matrix, it's going to search and give the recommended movies. So all these recommended movies, let's say the 5 movies, will be saved here, right? And then if there are no recommendation, again, if it's not present, it's going to say sorry, no recommendation found. If a movie has been given that's not present in the dataset, this is what the output is going to be. Whereas if we got a successful recommendation, it's going to say that top similar movies are these ones. But along with this, for a given movie, we are passing this movie title, the ones like that the user has given. So we are passing that to this get movie details so that we can get the plot and poster. So once we get this plot and poster, we are creating this container so that everything kind of looks packed. So in this container, we have 2 columns. So first we are displaying the poster, and in the next column, we are displaying the movie title and the plot. So it's like column 1 represents the left side part of the screen, column 2 represents the right side part. In the left side you have like the movie poster, on the right side you have the title and the plot. So this is the entire thing. Maybe I'll start the Streamlit app and I'll show you like how this entire thing works. And in order to run this, first you have to run the pre-process script. So that's important because that, as you know, that's how you first process this data and generate the DF and the cosine similarity pickle file, right? So now you don't see this. But in order to start this application properly, so I have added a file called as startapp.txt. So this has like all the comments. You can copy all these comments, paste it in your terminal. So in my PyCharm, I have my virtual environment activated. I can run all this, or I can just like individually copy and run these comments. So all you have to do is clone this repository or download the files in the same folder structure, run this commands one by one. And this is a folder structure. We have a folder called as src, which is the source code folder. Within that we have like the main.py file, we have the configurations thing and everything, so it's present here. And the API key which is present in the config is present here. Movies dataset is present here. This movies we need in order to do the pre-process step, and we have like all those scripts over here. And then along with this src, we have requirements.txt, which lists like all the libraries that you need. So you have Streamlit, NumPy, Pandas, joblib to load the files and everything. So all these are present. So the first step is to make sure like all the required libraries are installed. So you have to open your terminal and run this pip install -r requirements.txt. For me, it says requirements already satisfied because I've already installed it. And then I have to say cd src because this is the project directory. Movie recommendation app repo is the project directory, but the main.py file is present, main.py, and the pre-process is present within the src. So I need to navigate to the src folder. So for that, I can use cd src. So cd src is going to navigate to that directory. And now you see that the current directory that I'm in is like src, which contains the pre-process and the Streamlit run. So now I'll run this. So once you run this particular command called as Python preprocess.py, that's going to create all those pickle files, and all the processing step is going to happen, and you will see like all the logs over here in the terminal, as well as it is going to create like the logs in this particular directory itself. So it says like, the starting pre-processing, and some download thing has been completed, the dataset loaded successfully. So all these logs, right, we have kind of asked the code to write it like over here. So we say that create a file called as preprocess log. So this is what you're seeing here. So this gets created in the runtime. So we like save all the steps, whether a particular step is completed or not. So we are saying that, say that starting processing, whether the data set is loaded or not. If there is a error, say that it's failed to load. So all these are seen in the logs as well as the terminal. So that is the first step. So first we have installed the libraries, we moved to the src folder, and then we ran the pre-processing, and finally we run the Streamlit file, which is main.py. So just say Streamlit run main.py. So that is all. So this is automatically going to open the Streamlit app that runs on the port 8501. So here you can just like, this is the first movie, so it's kind of being selected by default. So I can click on this recommend similar movies. So that's going to take this movie name, find the recommendation, and it's going to come up with these 5 movie names as the recommendation, and later we pass this to the OMDb API and get the poster and the plot. So this is how this entire thing works. Now you can just like select here and search for, let's say, the Avengers Endgame movie, or you can just like click over here and just start typing. I'll say Age of Ultron, and it's going to like just click on this recommend similar movies, and now it's going to come up with the movies that are similar to this. If Man of Steel, the Superman movies is what you're going to type, just type in Man of Steel after clicking the drop down, press enter, and then it's going to recommend all the movies that are similar to that. So this is how this entire thing works. So please try this code, and I hope this would be useful to you. Like all these notebook files, dataset, and the scripts I'll give in the repository. You can check that out from the descriptions link. So that is all from my side, and I'll see you in the next upload. Thanks for watching.